Assalamu alaikum, my dear students. Bismillah ar-Rahman Rahim. This is your instructor Aisha Rehan for Computer Science, year 2020-2021. I hope you all are keeping well and you must have streamlined your daily routine. Please make sure to wake up early in the morning before attending your classes, may it be Zoom class or your Google Classroom. This is something very important to wake up on time and actually to embrace the change, to cope up with this new normal in a normal way. It's not like waking up directly from the bed and attending classes that keeps you lethargic throughout the class, and teacher can very well understand that who actually is attending class by just waking up or coming out of the bed. So this is something very very important. Please do not forget to have your breakfast, so to boost your energy and start your lessons with zealous fervor, so that you can actually get whatever is being delivered by your teachers. Okay, so coming to next slide, this is something very important I would like to discuss before I start my class. Children causing trouble between Muslims is a major sin that corrupts intentions in people's heart. Actually, breaking heart is a sin, and sometimes, for the sake of cracking joke, we actually convey wrong news, and other people being gullible, they believe whatever we say. So you have to understand that what difference actually you are making, your one statement is making in others life. If you are unintentionally spoiling relationship of two people, or you are creating mischief in the land, then you are actually doing a sin. And hukukul ibad has first priority, so you have to be mindful of the fact that your little act should not hurt anybody else on this earth. Okay, so coming to routine, what exactly we are going to do. Children, we are going to study fetch and execute cycle in detail. Okay, so this means last time I actually showed a video, and I will show a video again to you. By muting it, I will try to explain fetch and execute cycle, and by the end of the class you must understand all these steps taken in fetch and execution process. I will be giving you one question as well, as a reference question from CIE, to understand that which kind of questions can come in your paper pertaining to this particular topic, fetch and execute cycle. Okay, so moving ahead. Are you already charged up for fetch and execute cycle? Sit back, relax, and you have to understand very carefully what I'm saying. Okay, so give me 1 minute so I can start the video. This is a video I have taken it that contains a complete information of a von Neumann architecture, including fetch and decode cycle. Okay, so we will be explaining, I will be explaining complete details about it. The most important feature of von Neumann machine, children, is actually, a concept of a stored program that I actually told you in detail. Okay, data and programs are stored in the same memory space, and there's only one processor that execute instruction one by one. So once the one instruction cycle is made up of fetch, decode and execute. Okay, fetch, decode and execute. So we'll be studying all these things in detail. Now this is actually a complete layout of internal circuitry of von Neumann architecture. It contains lots of registers, out of which we are going to study these special purpose registers: PC, CIR, AC, MAR and MDR. The right hand side shows a complete picture of the memory. As I told you, that memory is divided into address and its corresponding contents. Okay, now here we have to perform the instruction of adding two numbers 27 and 35. So first instruction is actually, give me 1 minute, 500, that is going to be loaded in the program counter, as you can clearly see. So if you go to 500, its corresponding address is going to be copied in MAR, and its corresponding data will be copied in MDR. As over here you can see LDD 700 is going to be loaded where? It's going to be loaded in MDR. Okay, so 500 will be stored in MAR, and its address, its data, that is content, will be stored in MDR. It is soon copied to current instruction register, that is CIR. Okay, as soon as load 700, right now this is LDD, and we are not going into detail. This LDD, that is load 700, is copied. A program counter will be incremented to 501. Then comes a decode instruction step. Okay, that is, decode instruction means CPU is going to be, control unit is going to be in action, and it will copy the operand of the instruction to memory address register. That is, we are talking about 700. So MAR will be actually changed to 700, and MDR will actually contain 27. Okay, MAR contains 700 because this is decoding part. Decoding part means instruction is being decoded. So 27 will be in MDR, and as accumulator will also contain MDR. Okay, is it clear to everyone? Accumulator will contain MDR because it is the one where result is going to be saved. Okay, now program counter 501, that is add 701 instruction, is going to be copied in MDR. This means 501 will be loaded into MAR. Okay, MAR, since MAR contains address, its corresponding instruction add 701. Fine, 701 will actually come in MDR. It is copied to uh, current instruction register, and as soon as it's copied, program counter is going to be incremented to 502. Is it clear till now? I hope the concept should be very very clear, because this is the second one I'm explaining, second video I'm explaining. Okay, now if you go to 501, 501 says add 701. So decode, in decode part it will go to 701, and MAR will contain 701, and MDR will contain its corresponding content 35. Arithmetic and logical unit is not shown here. It will add 27 and 35, and after adding it is going to be stored in accumulator, that is 62. Okay, now 502 is the next address to be executed. So what is going to happen? It is going, 502 is going to be copied where? Of course it is going to be copied in MDR. No, MAR, right? Okay, so 502's content, that is store 702, is going to be loaded where? In MDR, right? Because 502's content contains store 702, and what is going to happen next? It is definitely copied where? In current instruction register. Okay, and program counter is going to be incremented to 503, that is end of the storing. After storing, there is end of the instruction. Okay, so now execution 503. So memory address register will contain what now? 503, you are right, it will contain 503, because it has to store 702, store 702. If you go to 70, sorry, not 503, 702, 702 will be stored in memory address register, and MDR will contain its corresponding address, that is 62. Children, this is the right mechanism that I explained you in the last class. So 62 will be written on that particular address. This is how things are done. Is it clear? I'm going back over here. When 702 is written, give me 1 minute. When 702 is written over here, 702 is the address, and when you have to write the content, you will write in its corresponding content. I hope the concept is clear to you now. Just give me 1 minute. Now you are ready to study fetch and execution steps in detail. What happens? The PC contains the address of the memory location that has the next instruction which has to be fetched. Agreed? This means PC actually has address of the next instruction. This address is then copied from PC to MAR via address bus. Copy PC is copied to program counter is copied to MAR, and next step is the content instruction at the memory location address contains in MAR are then copied into MDR. Content is copied into MDR. Fourth says that same contents are copied where into CIR, current instruction register. It should be remember that as soon as it is copied, PC is incremented by 1. The instruction is then decoded and then executed. Because if the instruction contains further instruction, that is to go somewhere and to add it, it will be executed in that decode instruction part. Is it clear to everyone? So moving ahead. Okay, this is the question I have taken from your past papers. These are kind of questions may come. The 7 stages in a von Neumann fetch execute cycle are shown in the table below. Put each sequence in the correct sequence by writing the number 1 to 7 in the right hand side column. The first one has been done for you. Remember, whenever this question comes, you have to read all so that you have clear understanding. So I'm giving you 1 minute to read out all so that you can tell me which is the next instruction to be executed. You do it on your own, and when you see that I am also doing it, you cross check your work. If you're doing it correct, this means you are on the right track. Otherwise, go back and watch the video again. Okay, so let's see what exactly is the first part. The PC contains the address of the next instruction to be executed. Okay, and the next is the address contained. Just give me 1 minute so that I can read also. The address contained in the PC program counter is actually copied to MAR via address bus. Is this two? Because this is the second thing. Okay. The third one is the instruction is then copied from the memory location contained in the MAR and is placed in the MDR data register. This is the third step. So what is the fourth step? The entire instruction is then copied from the MDR and placed in the CIR. And then PC is incremented. You know it very well. The value of the PC is then incremented so that it can points to the next instruction to be fetched. The address part of the instruction, if any, is placed in MAR, memory address register, to decode the instruction. The instruction is finally decoded and is then executed. So do you have the same sequence? If yes, this means you're on the right track. So moving ahead. Now, as an exit ticket, you must be able to answer all these questions I will be asking you. If you're able to answer, this means you're on the right track. My first question is, what is actually CPU's function related to fetch and execute cycle? So central processing unit is actually the one that contains all the registers for the execution of any process. Agreed? Now, next question. What are the function of ALU, control unit, and other registers? There are 3 important parts of CPU, and you must know arithmetic and logical unit performs arithmetic and logical operations, while control unit process signals and commands. Registers are storage area, temporary storage areas to perform functions. Okay. What is the calculator part of the CPU? If you are saying ALU, you are right. So what does ALU do? It's arithmetic and logical operation, and it performs all arithmetic and logical parts or operations of the computer. Okay. Then comes, I will take only our relevant part, control unit. It gets instructions, signals, commands from memory and interprets them. What are registers? These are temporary storage area for fast access. Instruction register, IR. Instruction register is one of the main type of registers where operations to be performed are stored. Operations to be performed. Okay. What are buses? It allows data to transfer around the system. What is a control bus? That deals with input, the CPU memory and output, and it carries signals and commands. Agreed? Data bus carries data. An address bus is unidirectional and carries what? Address. We are skipping the things that are not relevant. Von Neumann actually gave us the concept of stored program. Okay. Von Neumann model. He was a person, in fact. You all know function of MAR, MBR, PC and accumulator. If you're able to answer this means you are on the right track. Okay, so things to do. What you're going to do in your booklets now, you actually will be doing the question that I gave it to you as a past paper question. You will pause the video, copy that question and do it on your own. Past paper question must be done in your booklets. Okay, and you must be able to write about the registers PC, accumulator, MAR, MDR, sorry, what is this? CIR. Okay, so write functions of these registers and their acronym or a complete name of it. For example, PC, you're going to write a program counter, ACC, accumulator, memory address register, memory data register, and control instruction registers. I hope the concept is clear to you now. Give me 1 minute. Before taking exit, there's one short video, animated video to make you explain the whole concept we have studied so far. So are you all ready? Thank you so much. I hope the concept is clear to you. So we are all ready to start the new concept, inshallah, from the next class. Allah Hafiz. Take care of yourself.